Okay, here's the Z-axis video. Not much to it. It's different. The traditional Z-axis on a CNC will have your gantry, and then here's your Z-box. There's a little clearance here, and then on the Z-box you'll have these guides mounted to the back of that Z-box here, and then you'll have the bearing, and then the bearing block, and then you have a plate mounted to the bearing block, and then the clamp mounted to that plate, and then the spindle clamped into that clamp. So from here to here is quite a distance, and that introduces a lot of opportunity for leverage to be a problem. So I tried to eliminate some of that. What I did was I've got the gantry, or the back plate. Well, here's the actual gantry, and I've got so that's that surface. Then I've got 5 millimeters here, and this is my back plate, which would be this plate here, the back side of this, where these rails mount to. So I do have the rails mounted to that plate, but where my bearings are, I've got them enclosed in the same component that is my clamp for the spindle. So that allowed me to move my spindle back a long ways. And what I shot for was, I thought originally I was going to make plastic clamps. So I didn't, I figured I needed a good 1/2 inch of material here and here. So I designed the spindle until I moved it back until I had this. This is the upright here has to clear this back part by a few millimeters, and then you take another 12 or 13 here, and then your spindle, and then you just take your guide rails and you move them in and out. If you move them out further, you got more land here. If you move them in real close, you'll end up with nothing. So you see, wherever it ends up, wherever you squeeze it in, and you want it in as close as possible, because the wider you make this thing, the bigger you're going to have to make the table, and the more dead space you're going to have on the edges. So you want these in as much as possible. And even if I had gone into where there's a 1/4 inch of land, that's only a 1/2 inch more. But anyway, so I squeezed them in until I had about a 1/2 inch there, and then what it was is what it was. And then where this center to center located, that's where I put my rails, and I laid out the screw holes and took them right to the edge of this back plate on both sides. See? Now you can see it's wider than that up here because of these side plates, but the side plates don't interfere down here where they're hitting the walls. This is that width is what the shortest distance I could come up with. It's blurry. So that's how I designed the clamps. When I went to make them, I realized, this is going to get warm. Even though I've got coolant, I run them for a long time, so it's going to get warm, and this is just going to kind of get spongy and kind of melt a little bit. So I went to wood. Wood didn't work because it broke along the grain of the wood. So then I thought, well, MDF might work. Well, it turns out MDF is layers of some sort of paper thing, and they split lengthways. So when I went to put screws in them, it didn't work either. But I had this material on hand, so this is what I went with. If I didn't have this, I would have used aluminum. I probably would have used aluminum like a 1-inch straps, more or less, probably. This is what this was. I didn't see any sense in cutting it down. It's just more work. So I used it like that. Like I said, by doing it this way, it recesses the lead screw back in quite a way, so you have to clear for that. But once you clear for it, it works just like anything else. And I did leave. I left this bearing, this block, this pillow block off of it because it doesn't need it. It's using these rails to guide up and down. And you know, if you put a block down in there and something's not quite lined up right, all that's going to do is introduce a bind in it. So I just left that open. Can't think of anything else. Other than that, it's pretty normal. So there you go. There's the axis. Thanks.